Okay, so this is we're going to split chapter 3 is a very short chapter, maybe a week and a half long. And it's split into two parts. The first part is this logic that we're going to carry out throughout the rest of the year. And we've started hinting at some of this logic stuff already. And then when we get done with that, we're going to go back and do some algebra. So one of the things we didn't cover yet is quadratics. We'll spend the rest of the chapter talking about quadratics and a little bit of algebra practice here. So let's start with this. This is a pattern, and we would like to discover the next two in the sequence. So as far as patterns go, notice we're starting with the number 1, then 1, then 2, then 3, then 5, then 8, then 13. I want these next two numbers, and then the dot, dot, dot at the end means this pattern continues. Okay, this is what's called an infinite pattern, because theoretically it's going to continue on and on and on. So what are the next two numbers in the sequence?
19 and then 26.
I'm sorry, that's incorrect.
Wait. I know what the pattern is. I think I just added it wrong.
Okay, you want to help?
21 and 43. I mean 33. 34.
21 and 34.
How do you get right now?
Well, I was just going to ask him that same question. So, the answers are, in fact, 21 and 34. To generate that, we have something that's called the rule. So, Kev, what's the rule?
You add like two numbers, and then you get the number to the right. So like 1 plus 1 is 2, and then 1 plus 2 is 3, and 3 plus 2 is 5, and so
Beautiful.
on.
Do you know what that's called?
No.
Anybody? It's called the Fibonacci sequence.
Whoa.
Yeah. Which letters are next? No?
You tried, Jack.
Why? What's the rule? Some of these require you to think outside the box or have what's called a paradigm shift. No? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're going to get a lot of those. A lot of, You might want your calculators, by the way, for this one. In other words, get out your calculators. What do you got for the next two? Dan.
I got it in fraction form.
Okay.
It's 5, 6, and then 6 sevenths.
Or maybe that.
Yeah.
So explain that. What's the rule?
Well, the first one is 1/2, and then
No, the first one's 0.
0, and then it's 1/2. Then it's 2/3. Then it's 3/4. Then it's 4/5. Then 5/6.
But how does 0 fit the pattern?
0 zeros.
0 zeros is undefined.
I can
0 over 1.
Correct. 0 over 1. So what she recognizes the patterns, we have a fraction here where the numerator, the denominator from the previous one becomes the numerator of the first one, and you add 1. So 0 over 1, 1 over 2, 2 over 3, 3 over 4, all the way on forever and ever. How about this one? so other than just staring at it, what are you trying? Genevieve, I see your fingers working. What are you doing?
I'm trying to figure out this, but it wasn't working.
What were you doing? That's what I'm asking.
I was like trying to see the distance between like in the alphabet between each letter.
Oh, beautiful. So taking a numerical
Yeah.
approach to it. From A to E is B, C, D, E, 4.
Yeah.
But E to F is 1, so that's 4, then 1, then F to H is G, H, 2. So 4, 1, so you
Yeah, it didn't work.
didn't work. Okay. Not a bad idea. So taking the numbers and turning them into a mathematical sequence.
Never mind.
Is it OP?
It is not. Why did you think it was OP?
Because it's like some of the letters are like skipping out and it's like going in alphabetical order, except there's just some numbers or letters missing. I mean, and it's just like
So you were trying.
I tried to take out some letters. But
And how were you figuring? What pattern were you looking at that taking out letters?
I went from A and then I saw that they skipped B, C, D, and then they went E, F, and they skipped G, and then went H, I, they skipped J. And so
Okay.
And O,
And O is why?
because it went down like, never mind, I got that wrong.
Okay.
Oh, you were close. No, you had an N.
50%. Okay, why? So we eliminated the number sequence. We eliminated pulling numbers out because that didn't seem to follow any pattern. All right. What do all those letters have in common? This one's gonna make you angry when I show you the answer.
They all have like straight lines, they don't have any like.
Oh, they're all made of segments, no curves.
Oh my gosh.
I hate this.
B, C, and D have curves. E, F, G has a curve. H and I are good. J has a curve, etc., etc. What would be the next letter in the sequence then?
V. V.
V, correct.
B.
Good. I'll give you a hint. This one is purely mathematical. Jack,
17, 19.
why?
Because it goes up by 2 for 2 times, and then it goes up by 1, and then it goes up by.
Up 2, up 2, up 1, up 1, up 2, up 2, up 1. So you're thinking
Oh, 16 and then 18.
16 and 18. Not bad. Any other ideas? And actually, that's a good answer for this sequence. It's not a wrong answer. It's not what I had in mind, but it's not a wrong answer. I chose those numbers because those are composite numbers. What are composite numbers? Kev?
Would be divided by another number to like a smaller number.
Yeah, the opposite of composite numbers would be prime numbers. So these are the non-prime numbers. Strangely enough, when we start this then, the pattern that Jack outlined is also fitting into this, so we could have used that as the pattern. So Jack, staying with your pattern, what would be the next number? I forgot where we left off. Up 1, up 2,
No. 20.
20, which would also fit with my pattern. Then you would go to,
21.
right, then,
22.
yeah.
And then 24.
Yeah, so that pattern, your answer or your rule stays with my rule for quite a bit, and we'd have to figure out at what point, how high do we have to go before they start to diverge? And maybe they don't diverge, maybe it stays the same. This one I guarantee you're not gonna like. And by the way, the answer is not 200 and 500. How about I just tell you the answer and you tell me what the rule is?
You didn't give me.
think I got it.
You
Wait,
think
no.
so? What is it?
So 2 times 1 is 2, 5 times 2 is 10, 10 times, oh no, it didn't work.
No. It would work if the 50 wasn't there, or if
Yeah,
the 20
if
wasn't
the
there.
20 wasn't there.
Yeah. Any other ideas? Okay. This one's kind of a nasty one, but those are denominations of US money.
Oh my gosh.
$1 bill, $2 bill, 5, 10, 20, and yes, there is a $500 and a $1,000 bill, or there was at one point in time. Okay, this one is different. Notice I'm not looking for more numbers, and there's no dot, dot, dot at the end. Okay, so this is a terminating sequence. That's all you get. The question on this one is, why are those numbers in that order? I'm sorry, what? Ah, that's right. I picked the most confusing possibility.
There isn't one.
Ooh, that would be a jerk move on my part, but there is a logical reason why those numbers are in that order. Camille, what do you think? Emily? What?
No, I didn't have it.
What were you thinking?
Oh, it was wrong.
Down 3, down 1? Is that what you were counting?
I was like trying to like see.
You think so?
It's in alphabetical order.
Those are the numbers 1 through 10 in alphabetical order.
Oh my god.
E, F, F, N, O, S, S, T, T, T.
That's what I first.
Okay, so now we get into some terminology. Conjecture, as it says, is an educated guess. There's a big difference between a conjecture, which is an educated guess, and just a plain old guess. Caroline, how old am I?
I guess too high.
It's okay.
48.
Oh, your grade just went up. Now, why would you say 48?
Educated guess.
Why? Good. So you have information that you're basing your guess on, right? I'm standing right here. Okay, good. You're off a little bit, but a good guess. Caroline, what was my first dog's name?
Teddy.
Teddy? Not a bad guess. Is that a conjecture or just a plain old guess?
Just a plain old guess.
You have no idea what my first dog's name was.
What if you know if you had a dog?
I actually did have a dog. His name was Charlie. Well, my first dog was Charlie the third. We had 2 previous Charlies.
I'm assuming it didn't wolf it up.
They
Oh,
did,
Charlie's the
neither
same.
one. Untimely deaths for both of them. One bit the mailman, had to be put down. The other one committed suicide, ran out in front of a car. Charlie the third, though, lived to the ripe age of 16. He was a great dog. This process that we've been going through already is something called inductive reasoning. There are 2 types of reasoning. There's deductive reasoning and there's inductive reasoning. We're using inductive reasoning. Okay, and as it says up there, we're going from specific examples to general statements. And we've seen this already in practice. Okay, we draw 2 parallel lines. We put a transversal through it and we identify one angle and then we calculate all the angles and we start to look at the relationship. So we change the angle measure, do it again, redo the calculation, then we start to recognize patterns and then from those patterns we make a general statement. We're going to do that throughout the entire year. Unlike deductive reasoning, which is like Sherlock Holmes, what he used, he would go from a general situation down to a specific killer, for instance. We're going to go from specific examples to general statements. how does that all fit into place? Billy's preparing toast for breakfast. After a few minutes, the bread popped up, but was not toasted. What conjectures can you make about why the bread is not toasted? Let's hear from Lexi. What do you think?
Maybe it's not plugged in.
Beautiful, it's not plugged in. However, I will say my toaster won't click down if it's not plugged in. But good, one possibility is it's not plugged in. I don't know who makes toast without plugging in their toaster, but it could happen. What do you got, Rex?
Maybe someone stole the heating coils.
Right, right. So someone broke into the house and stole the heating coils out of your toaster. Left all the fine jewelry and the silverware and the widescreen
That's how you don't
TVs,
get caught.
but just took the heating element. Well, I mean, it could be weeks before you get caught, right? Because how often do you make toast? Caitlin, what do you got?
Like the degree of how much it gets toasted is like off or like.
Beautiful.
really
Some
low.
chocolate. Turn the dial all the way down to low. I like it. Cole, what do you got?
Maybe the toaster was broken.
There you go. The obvious one, the toaster's just not working. It's broken. Maybe someone stole the heating elements which caused it to break, or it just broke like most people's do. They didn't fall victim to the heating element toaster stealer. Okay, good. Anything else? All right, now those are all conjectures. They're conjectures because they're based on facts. And what facts do we have? Well, if Billy put some toast in the toaster, press a button, it didn't toast. In your notes, draw me what the next figure looks like. We're going from left to right, by the way.
Ooh.
Good one.
Can't even be so sure.
Right, could have been toasting it on the grill.
Can't even say that it fell out of the toaster.
Right, you might have been using a blowtorch on it. Yeah, what's the next one look like? Almost everyone has it, nicely done. Good. Alright. Hey, Tommy,
Yeah.
your diagram is correct. What color
Thanks.
would it be?
Oh.
Green,
Ooh, green, yes? You agree?
Yes.
Why?
because rainbow.
Colors of the rainbow. Good. There's also a numerical sequence here. What numerical sequence would we get out of this? Go.
+3.
Be more specific.
Oh, sorry. I screwed that one up, 'cause there's more.
How many blocks in the first one?
1,
Second one?
3,
Third one?
7.
6.
How many?
6.
6. How many in the next one?
10.
Are we sure?
1,
Yeah.
2, 3, 4.
Yeah, 10.
10. Is there a numerical pattern there? 1, 3, 6, 10.
Oh, it goes up by.
Good, yeah.
2, 1, 9, 3, 4.
We'll get rid of that. 1, 3, 6, 10.
5.
Bella.
Well, they each go up by 1 every time, so it's +2, +3, then +4, +5.
So the amount that we're adding each time is going up by 1.
Yeah.
Okay, so what would my next two numbers be?
It would be +14 and then 19.
+2, +3, +4,
Oh, 15 and.
There you go. 15, and
21.
21. Well done. Now that's one possible numerical pattern. Another numerical pattern we could set up. Where did that pattern come from? I'm not going to ask you to give me the next numbers. I hope, well, I don't want to assume it. Can you all tell me what the next two numbers in the sequence are?
5, 6.
Good, I'm so proud of you guys. Beautiful. Where did that numerical sequence come from?
The order of the numbers.
What's that?
That's the order of the numbers.
Yes, I know, but how does this relate to this? Good.
Like the bottom row.
Yeah, the number of blocks across the bottom. Okay, and then of course we could, this would have been a good, I should have thought of this before, but I could have done this as a numerical sequence. Tommy?
GI.
Oh, you're so close, GP.
Oh wait.
No.
Oh wait. Oh, it's B.
B, yeah.
Wait.
Yeah, you're right.
I don't know where I got I from.
Well, it's the next one. Roy G. Biv.
Oh,
Red, orange, yellow, green, blue, indigo, violet.
I think I'm pretty sure I thought G was spelled GI.
What?
Don't ask.
Well, there is a word GI, but it's pronounced gi.
Yeah, I know.
It's
That's
not an
not what I
English,
was
it's a
thinking.
Japanese
of, though.
word.
Well,
And it's nothing, it's a judo uniform, so it has nothing to do with this.
I was thinking of G, and I was like, well.
You were thinking of G like OG, like the original gangster?
Yeah.
Okay.
Definitely.
I got you, G. Alright,
Oh my god.
beautiful. At some point, we're gonna get to the actual logic here. Okay, so counterexamples. We're gonna use these a lot, and counterexample is what it says. It's something that proves it false. So for instance, if I say that all students in geometry are male, that would be a false statement. What would be a counterexample? Or I should say, who would be a counterexample? Raise your hand if you're a counterexample. Okay, there you go. We've got a bunch of them in the class. If you want to prove something false, you only have to prove it false once. If you want to prove something true, you have to prove it true for all of them. So if I make a statement that says all students that take geometry are male, I have to find every geometry student currently enrolled in geometry and prove that they're male. That didn't sound right. Let's just move on. That was a bad example. Don't use that example again. All right. Both of these are false statements. How do you know they're false statements?
Because 0 squared isn't greater than.
How do you know these are false statements? Because there's a sentence right here that says both of the following statements are false. Why is that one false? What's the counterexample, Charles?
Because 0 squared isn't greater than 0.
Okay, that's one possible counterexample. Any others?
Oh wait. Is it? Never mind.
Daniel?
Negative numbers with like this would be, so like -2 squared is 4. It's, oh wait.
That's what I was gonna say.
Okay, you just proved that part of it true. Stella? 1 is another one. Okay, so 0, 1, and also the other option would be fractions. Like fractions less than 1, so like 1/2. 1/2 squared is 1/4. 1/4 isn't bigger than 1/2. How about the second one? Ella?
Like all mammals do not bear alive young because platypuses.
Platypuses, platypi. Platypi. I'm not really sure what
Yeah,
I bet it's
I
with
think
B.
it's-
Platypi.
Yeah, I think it's platypus.
Plus platypi sounds cooler.
Yeah.
Right. That thing? That's a platypus. Yeah. By the way, did you know the bite of a platypus is poisonous?
Yeah.
Yeah, don't get bit by a platypus.
Why do you think Perry was such a good agent?
Right? He got in trouble, he just bite somebody and they die. Cover his tracks. Yeah. Okay, got a quick movie for you here.
Yay.
If it works. So I do have some questions, so watch carefully, because this does have to do with logic. Okay, so my question is, whose fault is it that she fell down the stairs? Ivy, what do you think?
It was her fault because she stepped back.
One potential answer is that it's her fault because she didn't look where she was going and she fell down this gaping hole in the floor. Jack?
The guy who opened it because they didn't tell her.
Yes, but I actually think it was a woman. But it doesn't matter.
I said
That person. That person right there?
Yeah,
Yeah.
and the guy because he
The
didn't
guy
tell.
who was told.
Yeah. Rex?
So anyone who saw it was open.
Right. This chucklehead walks around it, doesn't bother to tap her on the shoulder and say, there's a giant hole in the floor right behind you. Don't fall down. Is there any possible way that it could be that guy's fault?
That gets cool.
Let's watch it once more.
He was looking that way.
Is that guy in any way complicit with this situation?
He walks in.
But all you had to say is, hole behind you.
No, he's looking at something else. He doesn't even know. That's a really cool dude. He knows what's going on.
Yes or no?
No.
No, I think in a court of law he'd be okay. So, all right, good.
So we're gonna
Question?
What if he like owned the building and then he's the one that decided to put a hole that in the building?
Interesting. We could hold the, you think he's the owner, or are you just saying another possibility would be the owner of the
He
building?
could be the owner.
Or the architect, if you will.
Yeah,
Yeah, or the construction guy
yeah.
that decided to, instead of, we're gonna hide a trap door right behind 4 people.
Yeah.
Right, okay, good. And by the way, the woman that went down the stairs, or the person who went down the stairs, was probably killed when that woman fell out. We're gonna do a lot of work with if-then statements. We started doing work with if-then statements already. If blah, 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 then blah, blah, blah. That if-then setup is called a conditional. It's called a conditional because the second part is conditional on the first part. The confusing thing about today's lessons, there's a lot of words that start with the prefix C-O-N. So, if today is Monday, then yesterday was the weekend. What I don't care about right now is whether or not this is true or false. We'll talk about that later on in the slideshow. Right now, I just want you to get familiar with this setup. The reason this is so important is because all the definitions that we have been writing or will write in the future are going to take this form. Okay. If something is a line, then blah, blah, blah. If something is a segment, then blah, blah, blah. Okay. So that's the form that we're going to take, but it won't always be in that form. This first part is called the hypothesis. That's the if statement. The second part, the stuff with the then, is called the conclusion, another C-O-N word. The conclusion follows from the hypothesis. Okay, we good? As I've said for quite a number of times, we are mathematicians and we're lazy, and because of that, we abbreviate everything. Very seldomly we'll actually write out a full word. So when we get the logic notation, we'll shorten things, and we'll take full statements and just turn them into a letter. So if today is Monday, we can just turn into the letter P, or M, or whatever you want to use. And then yesterday was the weekend, we can turn into a letter Q. So that arrow pops up a lot, and that arrow means implies. And that gives us another way to phrase these statements. So we can say if today is Monday, then yesterday was the weekend. We can say Monday implies yesterday the weekend. We could say P implies Q. We could say M implies W. We can use whatever letters we want. But we want to be able to shorten things as we work with these. Okay? Like I said, Monday implies yesterday was the weekend. And as it says, we don't really ever talk like that, but it will save us quite a bit of hassles. Okay, so suppose we have it in a different form. All cows moo. I'd rather have that in if-then form than all cows moo. So what would that be in if-then form? first name?
I do.
What is it? Okay, good. I just want to make sure you can't answer a question. Why are there so many buses here for the band trip?
What is band trip?
It's a trip for the band.
Like,
So if you call the band trip B and you call the buses C, you can do B or C.
Yeah, great. Back to you, Emily.
why?
All cows moo. What are we starting with? Are we starting with mooing or are we starting with cows? Cows. Okay, so would the cows then be the hypothesis or the conclusion? Beautiful. So we need an if statement with some cows. You need a bunch of cows. What's that gonna sound like? I mean, don't moo. I mean, how do you put that together into a sentence?
She didn't say I don't know, to be fair.
Okay, good point. Shut up. What are we starting with? You just told me what we're starting with. Good, and what are those cows gonna do? Moo. Okay, so now what is that in if then form? If blah blah blah, then blah blah blah. Perfect. Perfect. If it's a cow, if something is a cow, if an animal is a cow, you can doctor it up, dress it up, however fancy you want to be. If something is a cow, then it moos.
Yeah.
Or again, being lazy, we could just say cow implies moo. Sounds silly, but it works. We will seldomly, if ever, go from if-then form back to all form. Most of the time we'll go from all form to if-then form. And again, when you're doing that, the question you want to ask yourself is, what am I starting with? Am I starting with something that moves, or am I starting with a cow? Okay, and that it's relevant because of what we're going to learn here, which is called the converse. Suppose we take that original statement, P implies Q, and we switch it. So it now becomes Q implies P. Whereas we started with a cow and we ended with it mooing, we can then start with something mooing and end with a cow. If something is a cow, then it moos. The converse of that would be if something moos, then it's a cow. And again, at this stage, we don't care about truthness or falseness. We just want to get the things under control. If yesterday was the weekend, then today is Monday. If something moves, then it is cow. And again, something could be animal, whatever you got there. Any problems there? Okay. Inverse. We have something called a negation. And a negation is when we take the opposite of that. So if I say, if something is a cow, then the negation of that is something is not a cow. If something is tall, something is not tall. You're not taking the opposite. So in other words, if I want to negate something is tall, you don't say it's short. You say it's not tall. Does that make sense? Because there's a difference between the two.
Yeah.
All right, good. So we're taking something that is not a cow, and it doesn't moo, because the opposite of mooing is not mooing. And then we, again, because we're lazy, we create a new symbol for that, and that's a squiggly mark from on top of the congruent symbol by itself, also known as a tilde. It's read as not P implies not Q. What's that a picture of, by the way?
A ball.
Nope.
An animal.
Nope. Nope.
It's a picture of a bull.
Nope. You're not gonna like this one either.
Ox.
It's a bull with no legs, also known as
Ground
ground beef.
Oh.
I don't get it.
Because it's on the
You
ground.
don't get, you want me to explain to you?
No,
It has
I
no
get
legs. It's a good one though, right? Contrapositive. Okay, so now we got a converse, switch the order. We got inverse where you negate both of them. The contrapositive is you do both. Negate and switch the order, so it turns into that. It's gonna get a little confusing here. And again, you got a bunch of CON words to sort out also.
Time.
By the way, going back to the last slide. This was what now?
A ground
Ground
beef.
beef.
Good. Do you know what you call a dog with no legs?
Doesn't matter, he's not coming.
What's that?
Doesn't matter, he's not coming.
There you go, good.
That's just dumb.
Oh yeah? Alright. What do you do with a dog with no legs?
Kill it.
No.
Well,
You
it's not
give it a
existent for
treat.
dog. You think
No,
it'll
you
walk?
take it for a drag. Alright, so now we'll test your comedic knowledge here. You ready for this one? So this is a 3-piece. So you got the first part, right? You don't name it anything because it won't come when you call it. You take it for a drag. What do you name a dog with no legs and steel testicles?
Oh, baseball.
Sparky.
Oh.
Okay, now hold on. Honestly, who understands that joke? Raise your hand. Okay. Explain it.
It's when you take them for a drag, like the sparks from like the friction of the steel. Oh wait.
Okay, so question.
Yeah, because he has a dog named Sparky.
Shut up. Oh, that's gonna be beautiful.
I don't know what that is. It's on my head.
Oh, I don't either. Okay, we have a lot more to go on this slideshow. So we'll obviously have to pick up where we left off tomorrow. However, I will unlock the homework. If you want to take a look at the homework and see if you can do a little bit of it tonight, that's fine. But we'll pick up with this house slide, so somebody remind me, we're starting with the house slide tomorrow. And we'll go through a bunch of examples to make sure you understand the difference between inverse, converse, conditional, contrapositive, counterexamples, all those other